Some faces are rejected instantly, not because they're ugly, not because they're strange, because something doesn't match. You don't know what it is, but your brain already decided. And once it does, there's no going back. You felt it before. You're scrolling. Everything's fine. Then you stop on a photo, and for half a second, your stomach drops. You don't know why. The face is symmetrical. The lighting is normal. Nothing is technically wrong, but something is wrong. This isn't paranoia. It isn't aesthetic preference. It's a 200,000-year-old alarm system buried in your brain, and it just went off. In the next 15 minutes, we're going to break down exactly what that alarm is, why it fires, why it catches things you can't even articulate, why it makes the CGI kids in that one Christmas movie unwatchable. And here's the uncomfortable part, why even knowing about it doesn't make you immune. Your brain has one job when it sees a face: decide if that face is safe. And it decides before you do. Let's talk about why. This is Factastrophes, innovation that changed the world. There's a piece of tissue in your brain, about the size of a raspberry, that has one job, just one. It's called the fusiform face area, or FFA, and it lives on the underside of your right temporal lobe. Neuroscientist Nancy Kanwisher identified it in 1997, and here's what's wild. This region doesn't do anything else. Not reading, not colors, not general object recognition. It is dedicated, hard-coded, biological face detection hardware. You were born with it already running. Babies less than an hour old, with eyes that can't focus past 10 inches, will turn their heads toward a face-shaped pattern, not toward a scramble of the same features, toward a face. Before they can see properly, before they've learned anything about the world, their brain is already hunting for human faces. This is why you see a face in a wall outlet, why clouds look like animals, why there's a man in the moon, why your car has a grumpy expression. Your FFA is so aggressive about finding faces that it finds them where they don't exist. Scientists call this pareidolia, and it's not a glitch. It's the system working exactly as designed. The design rule is simple. When in doubt, it's a face. Why? Because in the evolutionary environment, missing a face was fatal. A predator in the brush, a rival tribe member around the corner, a stranger approaching your family. You had one chance to spot them. So your brain evolved to err on the side of paranoia. Better to mistake a bush for a man than miss a man hiding in a bush. That's the upside. Now let's talk about the downside. Because the same system that keeps you alive is also the one that decides, in less time than it takes to blink, that someone is off. Here's the timing. If I show you a human face right now, your brain produces a specific neural response at exactly 170 milliseconds. Scientists call it the N170. It's a little electrical spike that shows up on an EEG like clockwork, and it doesn't care about effort or attention or what you were thinking about before. Face appears. N170 fires. 170. For reference, you blink in about 100 to 150 milliseconds. Your brain has categorized a face before your eyes are done closing for a blink, but here's the catch. That 170 millisecond response doesn't just say face detected. It's also running quality control. It's measuring proportions, eye spacing, symmetry, skin texture, whether the corners of the mouth move when the eyes do, whether the eyes blink at a normal rate, whether the head moves in sync with the breathing. And if any of those numbers are off, even slightly, your brain flags it. This is called thin slicing, and the research is frankly disturbing. People shown a face for less than 1 second can predict, better than chance, whether that person is trustworthy, dominant, or aggressive. They're not always right, but they're consistent, and they make the judgment before they can explain it. You've done this. Everyone has. You meet someone, and you instantly, without reason, don't like them. You can't say why. You try to be polite. You tell yourself you're being unfair. But somewhere in some part of your brain you don't have conscious access to, a decision has already been made. The creepy part? When researchers gave people more time to look at the same face, 30 seconds, a minute, 5 minutes, their judgment didn't really change. More information didn't override the 170 millisecond verdict. It just justified it. Your brain decides first. Your conscious mind writes the excuse later. And when it comes to faces that are almost right but not quite, that verdict isn't, "I don't like them." It's run. In 1970, a Japanese robotics professor named Masahiro Mori published a short essay that almost no one paid attention to for nearly 40 years. In it, he proposed a graph. On the horizontal axis, how human something looks. On the vertical axis, how comfortable you feel around it. He predicted that the line would rise as things got more human. A cartoon character is cute, a friendly robot is cuter, a toy doll is charming, and then, right before the line reached actual human, it would crash into a pit. He called the pit the uncanny valley, and for 40 years, Hollywood kept driving into it. In 2004, Robert Zemeckis released The Polar Express, a $165 million CGI masterpiece, motion capture performances from Tom Hanks, technology that had never existed before, and audiences came out of theaters saying the same weird thing. The kids in that movie are terrifying. They weren't wrong. The faces were anatomically correct, the movements were smooth, the technology was extraordinary. But the eyes didn't quite track the way human eyes track. The mouths didn't quite sync with breath. The skin didn't quite reflect light the way real skin does. And your 170 millisecond alarm system noticed every single one of those misses. 7 years later, Disney released Mars Needs Moms. It lost over $100 million at the box office. Same problem, in 2019, Universal released Cats, real human actors with digital fur, and audiences laughed at it. Because the human bodies moved like humans, but the faces had cat features, and your brain could not reconcile the two. Why does this happen? The leading theory is called the corpse avoidance hypothesis. For most of human evolution, a body that looked almost alive but not quite, stiff movements, glassy eyes, skin that didn't quite flex, meant one thing: a dead body. And dead bodies carry disease. Tribes that felt revulsion toward anything nearly human but not quite survived longer than tribes that walked up and gave them a hug. You are descended from the hug avoiders, that visceral nope you feel at a wax figure, a hyper-realistic doll, a corpse in a film, an early CGI character, a mannequin in a dim store. That's not a preference. That's a disease avoidance instinct your great-great-great-great-great-grandmother used to not die of plague. And now, it's ruining movies. Which brings us to right now. For the first time in the history of primates, a technology exists that can produce faces which slip past the 170 millisecond line. Neural network-generated images, the kind produced by tools like Midjourney, Stable Diffusion, and DALL-E, have gotten so good that studies now show people cannot reliably tell them apart from real photographs. Let that sit. The defense system that kept your ancestors alive for 200,000 years is being defeated in real time by a technology that barely existed 5 years ago, but not completely. Your brain still catches them. Sometimes. The clues are strange. AI struggles with hands, with the inside of mouths, with earring symmetry, with the way hair meets skin, with reflections in glasses. Your FFA will often trigger on something you can't name, and it'll be one of these details that your conscious mind never consciously checked. Your brain noticed. You didn't. This is the arms race of this decade. Your 200,000-year-old face rejection system versus a neural network trained on millions of human faces. The neural network is catching up. It's learning what your FFA looks for. And the creepy implication, the one nobody in Silicon Valley wants to talk about, is that at some point, AI-generated faces won't just slip past your alarm. They'll be better at triggering trust than real faces. Real faces have asymmetries, blemishes, shadows, pores. Real humans blink irregularly and fidget. A perfect AI face doesn't. And your brain, after 200,000 years of evolution, may learn to prefer the fake one. Here's the part that should bother you. The same system that catches zombies and dolls and CGI kids also makes snap judgments about real humans in real time, every day. Researchers have shown that people judge faces as criminal-looking or honest-looking in under a second, and their rate of agreement with each other is much higher than chance. Not because they're right, because their 170 millisecond alarm systems are running the same biased code. People with wider set eyes get rated more trustworthy. People with thin lips get rated colder. People with facial asymmetries get rated less competent. Your brain doesn't know these associations are unfair. It just fires. And there's a neurological condition called Capgras syndrome, where the visual face recognition pathway disconnects from the emotional pathway. Patients can look at their own mother, recognize her features perfectly, and feel with absolute certainty that she is an imposter, a perfect copy. not their real mother, because the facial match is there, but the feeling isn't. Which means the feeling you get when you look at someone you love, that warmth, that safety, that home, that's not recognition. That's a separate signal. And when it's missing, even if the face is identical, your brain sounds an alarm that no amount of evidence can override. The system doesn't care if it's right. It only cares if it's fast. So the next time you scroll past a photo and something makes you flinch, a face that's too smooth, a smile that's half a beat late, a stranger in a crowd who just feels wrong, don't ignore it. Your brain is doing exactly what it was designed to do. It's running a subroutine older than language, older than agriculture, older than fire. Every ancestor you have, going back 200,000 years, survived long enough to reproduce because their face detector fired a little faster, a little more paranoid, a little more willing to flinch at nothing than the competition. You are the heir to 200,000 years of flinching. Sometimes it saves you. Sometimes it betrays you. Sometimes it rejects a face for no reason you'll ever understand. But remember, your brain already decided. And once it does, there's no going back. Subscribe for more Factastrophes, where your own biology betrays you on a weekly schedule.